prior to plunging into the statement, it's crucial to handle the meaning of what we're examining. The Huge Hadron Collider (LHC), worked by CERN, remains a fantastic accomplishment in science. Traversing 17 miles, this mind-boggling organization of superconducting magnets isn't just the biggest, but also the most powerful atom smasher on Earth. It is an extraordinary representation of human resourcefulness and legitimate accomplishment. Strikingly, the LHC is strong to such an extent that it has the capacity to reproduce conditions like those during the universe's introduction to the world. Yet, as we investigate the infinity of the universe, could this machine, which plans to open the secrets of existence, unintentionally open us to more dangerous results? Founded in 1954, CERN is one of the world's most lofty scientific research institutions, including 23 member countries and an enormous community of analysts. It fills in as a center for collaboration and development. While the LHC is its lead project, it is only one part of a huge array of particle accelerators and investigations. Consider it a track, not for vehicles or ponies, but for subatomic particles racing against one another in a trial of speed, accuracy, and the nature of spacetime itself. At the LHC, protons are accelerated to nearly the speed of light, mimicking the energy levels present during the Big Bang. The resulting impacts produce temperatures that are far hotter than the center of the Sun. A series of magnets guide the protons on their way, while cutting-edge cooling systems maintain the temperature of the magnets at levels lower than space. The crashes are designed to happen at 4 distinct points around the accelerator, where specific detectors, ATLAS, CMS, ALICE, and LHCb, capture data. Each detector serves a unique purpose, providing a different perspective on the fallout of these accidents. Together, they act like massive cameras capturing the aftermath, with scientists sifting through the debris to reveal elusive particles like the Higgs boson, often referred to as the God particle, and other phenomena that might help us understand the building blocks of our universe. By focusing on the subatomic realm, researchers seek insights into the very nature of the universe. However, each new discovery just raises more questions. The LHC isn't just a tool. It represents humankind's unrelenting curiosity and hunger for knowledge. It encapsulates our drive to comprehend the forces that govern existence. Yet, as we push the boundaries of the unknown, we must confront the moral and existential challenges that accompany this pursuit. What risks could arise from digging too deeply into the unknown? Might our quest for knowledge ever open the door to forces beyond our control? At CERN, where the limits of human understanding are tested, a disturbing realization has emerged, one that has sent shudders down the spines of even the most seasoned scientists. Brian Cox, a former CERN scientist and a respected voice in the world of particle physics, has recently shared a disturbing statement that has both intrigued and frightened people worldwide. According to Cox, the purpose of the LHC is to recreate a miniature Big Bang. Yes, a small-scale version of the very event that birthed our universe. Cox also elaborated on the significance of this goal, explaining the vast potential of the LHC for pivotal discoveries, such as unveiling the secrets of dark matter, a mysterious substance that makes up a large portion of the universe. This opportunity to uncover the fundamental forces of the universe is certainly captivating, but it comes with inherent risks. The mini-Big Bang isn't just a theoretical concept. It is a real phenomenon happening inside the LHC. The collider recreates a state of extreme heat, pressure, and energy, mimicking those at the beginning of the universe itself. Perhaps we are witnessing the dawn of humankind's understanding of our origins. Yet with such enormous power comes immense responsibility. What if something goes wrong? This is not a new concern. In 1978, Russian physicist Anat Borsky experienced an incident that drastically altered the course of his life. While working with a U-70 synchrotron at the Institute for High-Energy Physics in Uza, Russia, a malfunction caused a proton beam to accidentally cross his path. The beam, traveling at nearly unimaginable speeds, pierced his skull, entering from the back and exiting through his nose. Although Borsky experienced a brief flash of light brighter than 1,000 suns, he remained conscious and even walked to receive treatment. The aftermath was both fascinating and disturbing. He lost hearing in one ear and suffered partial facial paralysis. Despite the severity of the injury, his mental faculties remained unaffected, and he continued his scientific work. Borsky's experience serves as a stark reminder of the power and potential dangers of particle accelerators. The risks associated with an atom smasher like the LHC are not to be taken lightly. There are serious concerns about unintended reactions that could alter the very fabric of existence. Some scientists worry about the possibility of creating a small black hole within the collider. Black holes are regions of space where gravity is so intense that nothing, not even light, can escape. They are mysterious, terrifying forces that lurk at the edges of the universe. The possibility that the LHC could create even a minuscule black hole is both mesmerizing and frightening. Could such a black hole eventually grow uncontrollably, devouring the Earth from the inside out? CERN scientists have reassured the public that any black hole created would be extremely unstable and would vanish almost immediately. Still, the remote chance of such an event has sparked widespread discussion and concern. To understand how the LHC might potentially create a black hole, we must first consider the basic operations of a particle accelerator. When protons collide at nearly the speed of light, the energy produced is so immense that it can distort the very fabric of spacetime. Imagine a trampoline stretched tight, and then a heavy object is dropped onto it. The fabric bends, and if the object is large enough, it could create a depression so deep that anything nearby would be drawn into it. This simplified analogy offers a glimpse into how the LHC could affect spacetime on a quantum level. At this quantum scale, where the laws of physics appear strange and bizarre, there is a theory suggesting the existence of additional dimensions beyond our familiar 3 dimensions of space and 1 of time. If these extra dimensions do exist, the LHC could potentially tap into them, possibly creating a gravitational well that forms a minuscule black hole. The possibility of such an event has drawn the attention of eminent physicists, including the late Stephen Hawking. In his work, Hawking warned of the potential for the Higgs boson to become unstable at very high energies, which could trigger catastrophic events such as vacuum decay. The respected astrophysicist Sir Martin Rees also raised concerns about the LHC's experiments in his book On the Future of Humanity. He explored the potential dangers of particle accelerators, emphasizing the disastrous possibilities of vacuum instability. He acknowledged that while the likelihood of such an event occurring is low, even a small chance warrants careful consideration. Much is at stake and the margin for error is razor-thin. Scientists at CERN have conducted extensive simulations and studies, taking every precaution to ensure the safety of their experiments. Brian Cox himself has acknowledged the concerns surrounding the LHC, emphasizing that strict safety measures are in place. Place these actions. Incorporate extensive surveys and conventions to guarantee that the collider's tasks are directed with absolute attention to detail. As per Cox, the energies associated with LHC tests are undeniably not exactly those that normally happen on the planet, and the possibilities of making a steady black hole are cosmically low. Regardless, even if one were to form it, it would be so little and unsteady that it would rapidly disperse, delivering an explosion of energy, as anticipated by Hawking's hypothesis of Hawking radiation. Some have estimated that the LHC's investigations could open a doorway to another universe or aspect. While this thought is generally excused by standard researchers, it has caught the imagination of many, filling fantasies and rumors. What lies beyond our universe? Might we at any point unexpectedly release forces or substances that we don't comprehend, potentially making a way for hell? This idea has even been sensationalized in media, enhancing the uncertainty surrounding these trials. But where did this thought come from, and what does it mean with regards to scientific investigation? The concept of parallel aspects is not new. String theory, a main competitor for a unified theory of everything, proposes that there might be more than the 4 aspects we experience, 3 of space and 1 of time. These extra aspects might be hidden from our senses but could, in theory, be accessed under extreme circumstances. Imagine the LHC as a key, opening ways to domains that have been hidden since the dawn of history. When protons crash into energies previously unheard of on Earth, they could create waves or disturbances that test these secret aspects. While this thought remains speculative, it highlights the appeal of the unknown. The possibility of discovering other aspects continues to intrigue the public, even though mainstream researchers remain unconvinced that the LHC will open a doorway to another universe or to hell itself. Nonetheless, the idea of the LHC being a grand key opening ways to new realities continues to captivate the imagination of many. So, should we be concerned about the risks associated with the LHC? It's easy to get swept up in electrifying headlines and fears of a catastrophic disaster, but in reality, scientists at CERN are very much aware of the potential dangers. They have taken every precaution to ensure the safety of their trials and regularly monitor and evaluate their work with the utmost determination. The potential benefits of their research, such as unlocking the mysteries of dark matter, discovering new particles, and expanding our understanding of the universe, are truly remarkable. While these achievements represent a significant leap forward in human knowledge, they come with inherent risks, like all major scientific advances. The LHC's trials raise important ethical questions. Might the creation of exotic particles or the exploration of high-energy conditions ever trigger unforeseen consequences for our planet or for the very fabric of reality? These are questions that cannot be answered lightly, and they require thoughtful consideration of the broader implications of science. All in all, the Large Hadron Collider stands as a testament to human ingenuity and curiosity. It has already made pivotal discoveries in particle physics, shedding light on the mysteries of the universe. But as we venture into these uncharted territories, we must remain vigilant and aware of the dangers involved. The quest for knowledge is perhaps one of humanity's most ambitious undertakings, yet it is not without its challenges. The LHC represents the cutting edge of scientific exploration, where theory meets experimentation, and where the very foundations of how we understand the universe are being tested. The journey of discovery is seldom without risk, and the LHC is no exception. It pushes the limits of physics, attempting to reconcile the fundamental forces of nature and answer age-old questions about the origins of mass and the nature of dark matter. But as we continue to explore these frontiers, we must acknowledge the significant moral and existential questions that arise from wielding the powers of the universe. The risks of unforeseen side effects, whether for our planet or for the fabric of space-time itself, remain a challenge that requires careful reflection. Nevertheless, the pursuit of knowledge remains one of humanity's most noble endeavors, and the LHC's experiments, while dangerous, offer a glimpse into the vast, strange realms of science awaiting discovery. As we stand on the edge of revelation, the journey to unlock the secrets of the universe demands both ambition and caution. The LHC represents the pinnacle of human technological achievement, as well as a powerful tool that could reshape our understanding of everything, from the smallest particles to the most awe-inspiring cosmic phenomena. With each breakthrough, there comes a wave of new questions, opening new avenues of thought and investigation. The journey of scientific discovery, though fraught with uncertainty, holds the promise of revelations that could redefine how we see the universe, our place in it, and the very laws that govern it. One of the most significant aspects of the LHC's trials lies in the convergence between theory and reality. For centuries, physicists have wrestled with the forces that shape the universe: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The hope has always been to unify these forces under a single framework, a theory of everything. The LHC has been crucial in providing insights and experimental evidence that bring us closer to this elusive goal. Its work not only advances our understanding of particle physics but also holds the key to unlocking the fundamental truths of existence itself. The moral dilemmas associated with such experiments are profound, but the quest for knowledge has always carried risks. However, when those risks involve altering the very fabric of reality, the stakes become much higher. Might an experiment at the LHC one day inadvertently trigger a phenomenon that we don't yet understand, leading to consequences that are difficult, if not impossible, to predict? It is a question that scientists, philosophers, and ethicists alike continue to ponder. As we venture into these domains, we must consider the responsibility that comes with wielding such immense power. Yet despite the potential risks, there are few who would argue that the pursuit of scientific progress is not worth the gamble. The rewards, new technologies, medical breakthroughs, and an expanded understanding of the universe are immense. The discoveries made by the LHC so far have already transformed the scientific landscape, from the identification of the Higgs boson to advancements in our understanding of dark matter. These accomplishments have far-reaching implications not only for physics but also for various other fields that rely on this foundational knowledge. As we push the boundaries of what is possible, the LHC serves as a reminder that science is never without its uncertainties. No experiment is entirely risk-free, and the LHC, however magnificent and powerful it may be, is no exception. Yet with each risk comes the potential for monumental discoveries. The LHC is a symbol of humanity's tireless quest for knowledge, a mission to answer questions that have eluded us for centuries. In the end, this curiosity drives us forward. The desire to understand the universe, to peer into the depths of reality, and to uncover the forces that govern everything, from the smallest particles to the largest galaxies. It fuels scientific progress. The LHC may carry risks, but it also represents the zenith of human achievement in the field of particle physics, a tool that allows us to explore the deepest questions of existence, challenge the very laws of nature, and seek answers to the mysteries that have evaded us for centuries. Whether the LHC will ultimately lead to the discovery of new aspects, open doors to parallel universes, or trigger unforeseen phenomena, we cannot yet know for sure. What we can be certain of is that it is one of the most powerful instruments ever created, capable of unveiling secrets about the universe that were once thought to be beyond our reach. The potential for discovery is limitless, and as we venture further into the unknown, we are reminded that science is a journey, one that requires both ambition and responsibility. Thus, as the experiments at CERN continue, we must remain mindful of the possibilities, the risks, and the unimaginable potential for new understanding that lies ahead. The LHC, while embodying the frontier of modern science, is also a reflection of our deeper quest for meaning and insight in an immense and mysterious universe. As we continue to unlock the secrets of the universe, we are reminded that each new discovery brings us closer to a fuller understanding of the forces that shape our reality.